So I'm going to talk about Node.js deployment patterns. I think it was I think on the schedule was Node.js in production. This talk hasn't changed, just changed the name. It's basically going to be talking about some number of the type of applications that you might typically run in Node and how I might recommend that you deploy them. And if you want to contact me, the details there. OK, so first of all, I'm going to break up into like 3 different main application types, architectures. I'm not trying to say that there are only 3 kinds of Node apps, but just a spectrum from very simple to very complex. And I'm just going to go through some tips. I'm also going to go into a bit of an aside about process monitors and Linux init systems. Along the way, some scaling and service discovery considerations, and as always, I'll talk about containers at some point. OK, so as I said, 3 different main types of applications, not as in types like IoT and mobile and web. I mean just like scale of complexity. So first of all, I'm going to talk about like a very simple web app where you've just got one thing to deploy. It might be one application that serves HTML and CSS or something like that. And then in the middle, something, or that also could be just an API, or just, but anywhere where there's just one thing that you're deploying. Then in the middle, something more like a website that has an API and WebSockets, probably a cache of some kind, database. I'll go into details in a moment. And then at the other end of the spectrum, like a really complex Microservices-y type thing with a message bus and all that kind of stuff. The kind of main theme I'll keep coming back to is basically don't overcomplicate things. It'll cause you some operational pain. And in particular, don't overcomplicate things prematurely. Make it as complex as it needs to be and keep it as simple as you can. OK, diagrams is not my skill. I have other skills, so sorry about those. So basically, the simple one is where you just have one thing to deploy. It probably talks to some kind of backend. It may or may not, but from the point of view of the person like listening to this talk and deploying something, you've got one thing to deploy. It's a Node app, and it's like one service. OK, so some properties of that. One is that they're very easy to scale horizontally. You can both within one host and across hosts. You basically just run a bunch of processes on that host and then scale them horizontally, put it all behind a load balancer. It's pretty simple. One of the reasons why this model is particularly simple is because there's no communication between the different components. You don't have like say like an API talking to a cache. You've just got one service. It answers requests. It sends information back. And basically, all you need to do for that is run one node process for each core on your host. So you've got a 4-core VM of some kind, 4 processes, some sort of load balancer on the host. It's the kind of thing that PM2 gives you. And then just scale them across boxes for however much traffic you need, and put all that behind a load balancer and a DNS. Like, this is pretty basic stuff. It's a very basic application. For the load balancer, you might use something like Nginx, HA proxy, or even something as simple as balance, which is like a few hundred lines of code, TCP load balancer written in C. It's been around like 15 years. It's fast, it's simple. You don't need much more than that. There are a bunch of things you can use, but that's a nice, simple example. So my recommendation for applications like this is to use systemd would be my choice. But generally, I guess my advice is to use a Linux init system because it is basically the ultimate process manager. It's PID1 ancestor of all your processes. Its job is basically to start and stop and restart services when they crash and when your system reboots, which is basically what a process monitor does. And I'll go into a little aside about those things. So in the Node world, we have probably these 4 main ones, at least were the ones that came to me, that are the most common. Mon, NodeMon, Forever, and PM2. The first 3 are pretty simple process restarters. When it crashes, it'll restart it for you. I'm sure they maybe do more than that, but that's basically for the purpose of this talk what's relevant. Whereas PM2 is different. It does a whole lot more. It's very good. It restarts processes, but it also does logging, gives you a sort of nice interface for all your applications that are running in it. It clusters ports together, so it has a built-in load balancer. And you can do monitoring, and you can also optionally hook it up to key metrics services for monitoring. So very powerful, very cool. Not intending to say anything negative about it at all. But nevertheless, my personal choice, I'd say use systemd. And the reason I say that is because, well, I'll justify it a bit more on the next slide, but You can recreate pretty much all of the core features of what PM2 does for you very simply with something like systemd and balance or any other load balancer. And there's a talk where I did that from scratch in like 20 minutes, and you can watch it. It was a NodeConf Oslo on the Upbeat site. You can watch it there. So if you want to know how to do that, watch that there. I'm not going to go into it. But basically, the reason why I think this is important is because the reason why I think you should do this is one that the tooling is really good. So journal control. So any sysadmin that's working on systemd will use journal control to look at kernel logs, system logs, application logs. You can slice them in different ways, look at them across the system, per unit, per service. You can specify time. Well, all the things you might expect. It's really powerful. And I think it's more powerful than any node-specific process monitor will be able to give you. If you run things with systemd, I think you'll also have a lot more control. You'll be able to choose your components, choose how you do logging, choose how you do monitoring, choose the load balancer that you use, tune those things as much as you like. And also, you'll be able to run all your non-node applications in the same way that you run your node ones. So from a sysadmin's point of view, they might be thinking, okay, here's how we run our applications. Then you give us a node application and you want us to run it with PM2. They might be like, why can't we just run it in the same way that we run everything else? So I think that's another good reason. And any sysadmin will be able to understand it because that's what they do day in, day out, using Linux to do their jobs. And when the Linux admin systems, when the Linux init systems have been doing this job for like decades, that's kind of like we already have this functionality. So I think good to stick to proven things, not that PM2 isn't proven or these things. I really don't mean to say anything negative about it. It's very good. But it's just my preference. And I think it's always good to learn more about the operating system on which our apps are run. So that's the end of that. OK, so on to the second type. So just to recap that one, what I'm saying is that for the simple web app, basically systemd and a load balancer per host, and put all the hosts behind a load balancer. And if you want, you can use PM2. It basically does the same thing. Cool. So for the middle one, this is basically, I think by the time you have a website with these kind of components and you get it to production, you've done all sort of load testing, performance testing, and this kind of thing. Maybe it's been in production a while. It'll probably look something like this. You've got your website, talks to WebSocket servers, APIs. You probably have some sort of cache that goes with that. Maybe that's Redis. Your WebSocket servers may also talk to Redis. You probably have some sort of backend database, that kind of thing. So it might end up looking something like this. It's not important that it's exactly the same, but just to depict the kind of complexity I'm talking about. So these are also quite easy to horizontally scale to some extent, less easy than the others because they're a bit different. But you will be running multiple versions of your API service, multiple versions of your WebSocket service. One of the things that complicates it, in fact, probably the main thing, is the fact that there is communication between components. So WebSockets, API service needs to talk to Redis. WebSocket service may also. They need to talk to a database. So when you have multiple instances of, say, of any one component, and you need one service, you need to configure one service to tell it how to talk to that, how you specify that, and whether there's load balancing in between. This is the problem of service discovery. So by having a more complex application, we introduce this problem that we need to solve, and we want to do it with as little complexity introduced as possible. The other thing that's important is host affinity becomes relevant for your services. You will want to have, say, Redis running on the same host as your API service. I would say it doesn't have to be, but it will be faster that way. You'll want to close it off to the outside world, that kind of thing. So you can't simply throw the services at a scheduler and just say run them wherever. It's like you have some constraints that you want to specify. So, and also you want your database to be on some host that has an SSD and that you're backing up, of course. So this also complicates it. So how do we introduce service discovery without introducing much complexity? I would say for this, you probably want to use something like, well, there are a bunch of options. There are many ways you can do it. So one is to use things like CloudFormation, Elastic Beanstalk if you're on AWS, because you'll be able to express the kind of constraints enough to be able to solve these problems. Or a platform as a service like Google App Engine. So I'm glad you got an introduction to that earlier, so I don't have to go into that. But that will also, underneath, it's using Kubernetes, which is, or a Kubernetes-based platform, which is quite complex, but that's all hidden from you. At your level that you're using it, it's actually really quite simple, and you'll be able to express the kind of constraints that you need in order to solve this problem without introducing too much complexity. Probably the way I might do it, because I just like these tools, but probably something like CoreOS's Fleet, which is a project that, whereas systemd is a thing that starts, stops, restarts your services, among other things. Fleet, for one machine, Fleet is basically an abstraction for that to make your cluster appear like one machine, and you can express constraints about scheduling. And it will introduce the complexity of etcd, which is something you may not want to do, something to keep in mind. But if you've been using systemd when your application was simpler, the transition to something like Fleet is quite easy because you're already expressing your services as unit files. So that's another option. And you'll need a dynamically configured load balancer reverse proxy of some kind to say that when things get scheduled across different hosts, they move, they get added and removed. So this is another item of complexity. But you say you wouldn't want to do it for a really simple application, but something moderately complex, I think it's a good solution. You could also use Docker Swarm, the new Docker Swarm that is in Docker 1.2, which is very green at the moment, not particularly proven, but if you're starting a new project, it's probably a good time to try it out. And that's because it's quite simple. You can express, again, the kind of constraints that you have about what runs where quite well using something like that, and it's really simple and easy to use. And I think also once you get to this stage of complexity, then containers become quite helpful. You might have a heterogeneous stack, using different languages, things like that. Different versions of Node, even if it's all Node. But it's nice to just say, I just build an image, and I deploy that image and run containers. It's the same artifact. It's nice, simplifies things. I keep doing that. So the final one. Wow, I must be speaking really fast, because I've done this about 7 minutes faster than I did earlier today. Cool. So so the final one is something more complex, a distributed microservices-based system. So this is arbitrary, of course. Doesn't matter what your architecture is, but something that's got basically a bunch of services where you no longer want to think about individual services because there are too many. You want something to handle things a little more for you. So I'm just imagining you might have PubSub and a bunch of microservices on the back of the same diagram I had before, something like that. Okay, so you don't want to be thinking in any way about plumbing. You don't want to be kind of adding like IP table rules for particular ports. You don't want to be adding AWS EC2 security groups for certain services. You don't want to get to this kind of level. It's too much because you have too many services. You don't want to be specifying exactly what runs where, because again, there are too many. Basically, what you need is a declarative platform with service discovery, and it will manage things for you. It will scale things. Sorry, if a few services go down, it'll start them, reschedule. If a host goes down, it'll wait for another one that'll reschedule things. And always try to get your application back to the state that you kind of declared. I want 5 instances of my API, 3 instances of WebSockets, that kind of thing. So that's kind of what we're looking for. And so I would say here's the perfect use case for Kubernetes, because it's designed for exactly these kind of applications. All the things I said on the previous slide, it'll do that really nicely. Which implies you need to containerize your services, and I think by the time you get to this level of complexity, that becomes really beneficial to do anyway. I don't want to get too much into containers, but also you can use Kubernetes in hosted platforms such as Tectonic or Google Container Engine, on top of which is built Google App Engine, which will also do all this stuff and work quite well. You can use other Kubernetes-based platforms as a service, such as Deis, which has a really nice developer workflow that's similar to Heroku. It's really nice to use. Maybe someday the new Docker Swarm will be ready for this, but I think it's just too new at this stage. We don't know how it's going to scale to this kind of level of complexity, but presumably that's what they're targeting. Okay, so just to kind of wrap up, I think most importantly the message is keep it simple and don't prematurely complicate your stack or you'll cause you some pain. You might think that, this thing I'm building is going to have loads of users someday. I need to build that in from the start. It needs to scale. It needs to be, I don't know, web scale or whatever you might want to say. And you might think, okay, it has to be Kubernetes. It has to be this, it has to be that. Until that happens, it's not true. You be the judge, of course, but I don't think that's a particularly wise approach. And being 12-factor is a great idea because I think this has all just come so natural to us these days, I think. But when you do build things in a 12-factor way, things are sort of stateless, and they're sort of configured from the outside with things like environment variables, then it becomes very easy to port your application across these different platforms. So to take a 12-factor application from something like a single host, single type, a single service, something with systemd. no problem, to something like to Fleece, and then onto various platforms as service, or right up to Kubernetes, then being 12-factor along the way just makes that really easy to move across. And containers help if your application is sufficiently complex. This is one of the biggest things about containers for me, that you can develop and debug your application, perhaps your whole system on your laptop. There's a lot of talk about containers and like security isolation and C groups and namespaces, but I think the big thing about containers that the revolution that's going on with Docker in particular is the developer user experience, just being able to like bring stuff in like this and the way you can. I'm not going to go off into a rant about containers, but this is very important. And and as I said before, having homogeneous deployment artifacts for potentially heterogeneous stack is really useful, makes things very simple. Of course, test everything, but when you're, so we're talking about deployments here, I think something that's very important is to be able to, in fact it's critical, is to smoke test your releases after they've gone out. So you want to do some non-destructive requests in your system to make sure that everything's okay. And you want to have a way to be able to roll back quickly and easily. And I think systemd is the way to go. Okay, thanks very much. If you need to contact me, that's my details.